I'm going to show you some workbooks that we created for the Excel Companion to Political Analysis. You can download these workbooks from the Excel Companion's website. The URL for downloading these workbooks is in the video's description. We created two workbooks to help students do statistical analysis and get a better understanding of inferential statistics. We use these workbooks for examples in the book and encourage students to use them to solve some chapter exercises. The Significance Testing Workbook contains worksheets to help you create confidence intervals, test hypotheses about sample statistics, and analyze regression residuals. To use this workbook, you usually start with some basic information about the sample data you're analyzing, like the sample mean and sample size, and then you input that information into a worksheet which does the statistical analysis for you. The Probability Distributions Workbook contains interactive worksheets for all the probability distributions that Excel knows. You work with probability distributions like the normal distribution, student's t-distribution, binomial distribution, chi-square distribution, and f-distribution a lot doing political analysis, and this workbook gives you a chance to interact with these distributions and see what they look like. Let's take a quick look at both workbooks, starting with the Significance Testing Workbook. Here we're looking at the cover page of the Significance Testing Workbook. This workbook is a collection of 9 worksheets we made to help students do things like construct confidence intervals for sample statistics and conduct null hypothesis significance tests and analyze the normality of regression residuals. We made this workbook to really simplify as much as possible these techniques of political analysis. I think frankly sometimes textbooks make them more complicated than they need to be for students who are learning to apply these methods, because the methods follow set protocols and procedures and don't need to be improvised by the student or memorized as a series of steps, because the steps are already known and the student is really just trying to apply the steps and apply the procedures to a problem, to solve a problem, or to use statistical inferences to aid the analysis. The inspiration for this workbook and these worksheets really came to me when I was reading a text on using Excel for data analysis, and it had a nice description of constructing confidence intervals using Excel and showing it as a series of steps and applying statistical functions and calculating critical values and then looking up values in a probability distribution and identifying the degrees of freedom if it was a mean. And it got to the end of this rather elaborate multi-step description and said something like, and you can create a worksheet to do these things for you to really simplify the tasks. And I kind of rolled my eyes at the text and said, well, why don't you create a worksheet to do these things to simplify the task rather than telling us to do it? And then I said to myself, well, shoot, why don't I create a worksheet to do these tasks to really simplify all of these steps for us and just concentrate on what needs to be inputted by a student to solve a problem. I have some separate videos for using the worksheets, and I'm not going to try to go over all of them now, but just want to maybe click through a couple of them and show you what I'm talking about here. So we're looking at the cover sheet. So we have several for calculating confidence intervals. Let's look at the confidence interval for a sample proportion. And I said, like, this can be somewhat complicated when you read it in a textbook, and it is good to know the steps and where the numbers come from and how it gets calculated. But in reality, for a problem like this, the confidence interval is a sample proportion. There are only three inputs you ever use. You input the confidence level, which is almost, I wouldn't say almost always, usually 95. It could be higher or lower than that depending on the problem you're working on. But you've got your confidence level, the sample proportion, and the sample size. All the calculations that are done to create a confidence interval, where you would find the standard error of the proportion find the critical value based on the confidence level, apply that to create a margin of error, apply your margin of error to the point estimate to get a lower bound, upper bound, all those steps, all like those steps that the book I was referring to, I won't name to embarrass the authors, but the book that I was referring to, it laid out all these steps, step by step, and said, for a student, do this, then do this, then do this, then do this. When in reality, the steps are known, and you can program them into a worksheet, and you can see the functions we've inputted into this worksheet to calculate the values and generate a graphic. But in reality, there are 3 inputs you need to make, and you usually would get these from the problem you're working on, or maybe analyze a sample yourself and say, I've analyzed a sample, there are 450 observations, and a sample proportion of people who said yes or people who were in favor was 0.71. You input those things, and then you get a confidence interval. And you can see it, and you get the values. So I think it simplifies the task quite a bit, but that's just one worksheet. We also have some worksheets for conducting null hypothesis significance test. Like, for example, here's our one sample mean test. It's usually called a t-test, but it's a one sample mean test. You're testing whether a mean in a sample is greater, less than, or equal to, or not equal to, hypothesized value. So this is showing where you input the hypothesized value, and then information about the alpha, your error tolerance, information from the sample about sample mean, sample size, and then indicate some assumptions you make about the standard deviation in the population and whether that's known or not. And so these are all the inputs you would need from the problem you're working on. But then the beauty of the worksheet is once you check the boxes and make the inputs, it performs these calculations for you, finding the standard error of the mean, determining which test statistic to use and calculating that test statistic for you, then applying that test statistic in comparison to a probability distribution to arrive at the p-value. But all this work, these internal calculations these steps are known, these protocols are known, and so they're inputted in the worksheet to make that accessible to you to see how it's done, but then allow you, the student, to focus on the inputs that would be unique to the problem you're working on. The hypothesized value, the direction of the hypothesis. In other videos, we'll go through this more closely if you're worried about wondering how to do this one sample mean test, and we'll cover that. But you can see the general idea is simplify it as much as possible to reduce the number of inputs you need to make just to the essential inputs that would be unique to the problem you're working on, and then as much as possible have the worksheet do the computations and analysis for you, and have the workbook deliver useful results to you, like the p-value of the test you're working on and the conclusion you would draw. Like in this case, for this example, you would reject a null hypothesis. So that is what we've got in our significance testing workbook. I think students who've used it have found it very helpful. Once you get the handle on the information you extract, how you put it in there, it does a lot of the work for you, and then you can concentrate on properly interpreting the results. The computations and calculations really can be done by a worksheet. That is the beauty of a computer program, and using software like Excel, the computations can be stored and the protocols can be programmed into a worksheet, so you can concentrate on what's unique to your problem, letting the machine do the difficult math and statistical analysis and computations, and then delivering the results to you and leaving it to the user to properly interpret the results. Here we're looking at the cover page of the probability distributions workbook that we created for the Excel companion to political analysis. As you can see, there are quite a few worksheets contained in this workbook. We have several worksheets for estimation simulations, where we're using a computer to generate a lot of random numbers to look at the expected distribution of sample statistics. An example with population proportions and population means, as well as one to show the estimation of a population standard deviation. And I think those are fun hands-on exercises, and we've got some separate videos to work through our examples of estimating population proportion or estimating a population mean, and looking at, if you're using random samples, how close you would get on average to the population parameter using your sample estimates. We have a couple other worksheets to show you what the sample distribution of a proportion looks like, or the sample distribution of a mean looks like, where you would, let's just click over those pages. So you would, like with a sample distribution for sample proportion, there's two inputs here. You input the population proportion as well as the sample size you're using to estimate that population proportion. And then when you modify the inputted population proportion, you'll see that the figures change. There's only 100, so this will change pretty subtly, but you can kind of see the PDF and the CDF of the distribution change. So this is pretty useful. If you're saying like, I'm estimating a population proportion with 50 sample size, I think hypothetically the true value of the population proportion is 0.358. Well, if I repeatedly drew 50 observation samples, this is what the sample proportions from my estimates would look like. They center on the true value, but you can see it fans out and spreads out in a fairly characteristic pattern. And I think it's fun to be able to look at that and see how, if, for example, you lower the sample size from 50 to, say, 30, how that changes the shape of the distribution. If you lower the sample size, it's going to widen the distribution and lower the peak. And if you enlarge the sample size, you'll get a sharper estimate with a higher peak and less spread out estimated values. And then you have a section of multiple worksheets of interactive probability distribution. So probability distribution is a statistical concept where an equation is used to model the distribution of some sample statistics, or to model a data generating process. And some of these are used in the workbook. I cover all the ones in Excel here, but then some of these are featured in the workbook a few times, and I think it's helpful, when you encounter or try to use a statistical distribution in the analysis, to take a look at it. These are kind of abstract concepts, but the workbook, and when you can interact with it, lets you work with it hands-on and manipulate it and see how it responds to your inputs and manipulations, and give you, I think, for students, a better sense of what these things do and what they look like and how they respond and what the parameters of these distributions are. Let me show you one example. I don't want to make this video too long, but I do want to show you at least one example. This is the chi-square distribution, and the chi-square distribution is one that is talked about in a chapter, at least one chapter in the more than one chapter, but at least one chapter in the text, where we use the chi-square test of independence, and that generates a test statistic, and that test statistic is compared to this chi-square distribution. And so with this workbook, you can kind of see what this looks like, the chi-square distribution. You have these two views of it here. You have the PDF, the probability density function, and a CDF, the cumulative density function, and you can see these shapes. It's sort of a interesting shape here, not exactly symmetrical. It has a longer right tail, and you get a CDF of it, and you can see where the x-axis value crosses over, say, 0.5 or 0.95. And I think one of the neat things about this chi-square distribution, there's only one parameter to it. So there's only one input to control what this shape looks like. And here I'm showing a df, degrees of freedom, that's the parameter, of 7. What if I decrease it? How will that change the shape? Well, let's try it. Let's click down to 6, or 5, or 4, 3, 2. Now look at this shape. chi-square distribution with 2 degrees of freedom. Notice it starts at 0.5 and then slopes down pretty quickly, and then the CDF starts at 0 and rises pretty quickly. This includes some interesting information about the chi-square distribution, like its critical values. So with the alpha of 0.10, the critical value is 4.56. What does this mean? Well, 4.605 would be about here. It doesn't have the 5 here, but so it would be about here. This is saying that 10%, 0.10 of the density of the distribution is to the right of 4.6, and 90% of the distribution is to the left of 4.6. You can see that here on the CDF. If you come out to 4.5 about here and then move up, that is the 0.9 value. 90% of the distribution is below 4.605 and only 10% is above. And you'll see in the book that these values, the settings for the chi-square distribution, but also the critical values, are used to test hypotheses using a chi-square test. You can get a chi-square test statistic and you could compare it to the critical values to see whether that test statistic is something that you're likely to see from a chi-square distribution with 2 degrees of freedom. For example, if you had a test statistic of 15, would that be would you be likely to see that from a chi-square distribution with 2 degrees of freedom? No, that would be a pretty extreme value. 15 would even be off the charts here, and it would be almost all the values you would obtain from a chi-square distribution with 2 degrees of freedom would be less than 15. But if you change the settings, you can get some different results. If you increase the degrees of freedom, well, now with this new settings, a test statistic of 15 isn't so great anymore. So that's just one of the pages that's included in the workbook. On your own, you may want to explore the F distribution or the binomial distribution or the normal distribution. These are all really important distributions, not to mention the student's t distribution as well, that we cover in the book and that are used for statistical inferences. And hopefully these pages and the ability to interact with these pages and see the shapes can help demystify the distributions, let you see what they look like, what influences their shape, what are plausible or implausible values. So I think these things are usually kind of hard to work with hands-on, and I think this workbook and these pages in the workbook give you a real chance to work with these distributions hands-on and understand how to use them and how they're useful.